All right, mathletes, here we are going to be talking about feasible regions, and that's specifically of feasible regions of graphs. So in this first example we're going to be looking at Jason and Kate, and they're given $20 to set up a barbecue for a school event. So as they're going there, they decide that they're going to buy two different meat options for their barbecue. They go to their butcher and they get a price. So the butcher gives them a quote. The first thing they say is sausages they can get for 40 cents a piece, and steaks they can get for $1 a piece. Okay? So what we want to do is we want a visual representation of how we can see the options for what they could buy with their $20. Okay? So one way to best think about this is to set up a table and think about what would happen if they bought 0 of their things. So first let's get our variables. So first we're going to say X is sausages. Okay. Next I'm going to say that my Y is my steaks. Okay. So let's say if I bought 0 sausages at $1 per steak and $20, I'd be able to buy 20 steaks for that barbecue. Well, for the other scenario, let's say we buy 0 steaks. Sausages are 40 cents a piece, and with $20, I can buy 50 sausages for those. Notice this is very similar to how we would graph a general equation. So let's go ahead and start graphing that. So we get a graph at 20, okay, 0 and 20, okay, and we'd also get a point at 50 and 0, okay. And there's a whole list of other options in between, and those are options that fall on the line as we graph that. Okay, notice one option would be here for buying 25 sausages, and 10 steaks would include all our money. So to come up with this equation of our restraint, think about how we did it in our head. So first we said the cost of our sausage. So we know the cost of the sausage was 40 cents. Okay, we had the number of sausages being our X value. Okay, and then we had our cost of our steaks. Well, that was just $1, and delegating our variable of Y to the number of steaks. And that all adds up to our $20. So there we get our equation of our line. Well, we got to remember that our feasible region, we don't have to spend our entire $20. That we could also have an option down here where we buy 5 sausages and 5 steaks. Okay, we could also have an option over here where we buy 20 sausages and 10 steaks. Yes, we'd have money left over, but that's a feasible option for this scenario. So usually with our feasible regions, we are going to shade them. And that is what we delegate as a feasible region. Right? Notice that I'm only shading positive values. I'm not going to have things that are negative values. I could, in theory, buy 0, 0. I could buy 0 steaks and 0 sausages, although that would not make for a very fun barbecue. So we can have additional constraints on these things. So consider again Jason and Kate's school barbecue. When they went to their butcher, the butcher said they would only give that price if they buy at least 10 sausages and at least 6 steaks. Meaning we can't buy 0 and 0, okay? Or we can't buy 5 sausages and 5 steaks, okay? So what we have is additional constraints. So since they're just dealing with one variable, we are going to use our inequalities. And since the number of sausages we delegate as X, we say X must be greater than 10. So as we graph X is equal to 10, which is this line right here, we know that if we want values that are greater than 10, we are going to shade things to the right. Okay? And we know that before we couldn't spend money over $20, so this we were shading things to the below that general equation line. The other restraint was coming from our number of steaks that the butcher said. So if we wanted that price, we had to buy more than 6. Okay, we could buy 6. So then, because it could be equal to, they're solid lines. And notice when I graph y is equal to 6, it's this line here. But if I'm saying they can't be values below it, it has to be values above it. So as I look at where all these arrows are pointing, we get kind of our sum for our feasible region in there, shaded in the yellow. Okay, let's look at one more example here. So Steve buys X pineapples for 2 pounds each and Y watermelons for 3 pounds each. He spends at least two of each and can spend no more than 30 pounds. Graph the feasible region for what Steve can buy. So I'm going to start labeling things. So I know that X is my pineapples. I know that my Y is my watermelons. Okay, so I'll associate watermelons with green, and I'm going to associate pineapples with red. Okay, so again, if I think about my equation, okay, first I'm going to say, all right, if I have 0 pineapples, I'm going to buy. Okay, I would have 30 pounds to spend. Okay, and my watermelons $3 each. So that means I could buy 10 watermelons by themselves. The other scenario, if I buy 0 watermelons and they're $2 in each for a pineapple, I could buy 15 pineapples. Okay, so as I look on my graph here, I'm going to have, so if I'm counting up by 2, 4, 5, 2, 4, 5, 10, and then, so then 0, 10 is going to be here, okay, and 15, 0, so 2, 4, 5, 2, 4, 5, and 2, 4, 5, so there's 15, okay, that is going to be my other restraint, okay. So since we're just trying to graph the restraint, I don't need to worry about finding my equation, so it's just going to be this straight line there, okay. If I wanted to come up with the equation, I know I can take the 2 pounds times X, it's going to give me the cost of the pineapples, okay, plus the 3 pounds it costs for my watermelons, and then that this has to be less than or equal to the $30 I have to spend. So I have a solid line there. So since I could spend less, I know that my feasible region is going to be shaded below. I can't spend more. I only have $30 to spend. The other information I got to be able to use here is it says that he needs at least 2 of each. So what he needs at least 2 of, that means that my pineapples have to be greater than or equal to 2. And I also have to have watermelons that are greater than or equal to 2. So as I graph that, y is equal to 2 here. And since I have to have at least that many, I am shading above the line because I got to have at least 2 of each. I could have 2, so it's a solid line involving equal to. Now again, same logic applies to pineapple. Graph it here. At x is 2, and since x has to be greater than 2, I shade in that area. So where at the region, the feasible region they're all pointing to is here. So this involves all the different values at which I could buy a pineapple. For instance, if I look right here and say this part right there is going to be 5 pineapples and 4 watermelons, that 5 pineapples would give me a cost of, so if I put into my equation, I get 2 times 5, okay, which is going to be $10, plus $3 for all of the watermelons I buy. I buy 4 of them, so that's going to cost me $12. And I can see that 10 plus 12 is going to be less than $30. Okay, so this concludes our notes tonight on feasible regions. Please highlight any questions you may have and bring them to class.